Hey there! So we did it. We finished the ingestion phase. So today, that's the time to summarize this whole process, to celebrate our first milestone. Today, I will also give you a challenge that will allow you to practice all the stuff that I was talking about. And finally, I will talk about a prize for the person who completes the challenge as the first. So let's get started. Alright, so we finished this ingestion phase, the first phase of our data analytics solutions. So let's quickly recap what ingestion is all about and how does it locate in our overall solution architecture. So in case of basically every data and analytics solution, and please note that right now I'm talking about batch solutions, streaming will be covered later on, we usually start with various data sources. So the data sources, they might differ, but quite often we'll have to deal with such ones as various types of files, like some CSV files, XML files, JSON files, and so on. Those files, well, they can be hosted in multiple places. Maybe they are on some file share, maybe in SharePoint, maybe on someone's disks, who knows. Apart from files, what we often have to work with are different types of databases. Microsoft SQL Server, Oracle, MySQL, and so on, different types. And again, they might be hosted on premises, in your company network, or somewhere in the cloud, in Azure, in Google, in Amazon, and so on. We might also have to deal with various APIs, like REST API that we saw last time when I was talking about this replicable API. And overall, all of this stuff, these are just our data sources. And we know that we don't want to query those data sources directly. We don't want to build our reports on those sources for various reasons that were covered in one of the first episodes. So what we are doing in our BI solutions is to grab this data and load it somewhere into Azure. And this somewhere, in many cases, it is a data lake. So let's add a data lake to our diagram. So this is a big data lake, ADLS Gen 2. And we know that to provision a data lake, we have to create a storage account that has this hierarchical namespaces checkbox enabled. Then, when it comes about data lakes, we know quite a lot about them, right? We know what redundancy options are there, whether we want to configure it to be locally redundant or maybe zone redundant, because various types of those redundancy, they give us a different protection from various types of failures. So we have to choose the one that meets our requirements. We know quite a lot about access tiers, this hot, cold, and archive. That again, they highly impact the price, how much we pay for the data we store and access in a data lake. We know quite a lot about different file types we could use to store our data in a data lake. And what is also very important is that we want to organize our data lake. We want it to have some kind of a structure that is well defined to avoid this data swamp analogy, where all data is just dumped without any order. And what usually is created is a container, this top level object in a data lake. In my case, I'm just calling it row. Under which we would create a proper structure for various data sources, maybe also partitioned by the ingest date, and at the end at least in this row zone, we would store data as files using the native format. So here we might have CSVs, JSON, XMLs, Parquets, and so on. Alright, but somehow this data from data sources has to be ingested into a data lake. And we know that this is a very important process, and there are various tools we could use to make it work. From my experience, the most commonly used one, at least from Azure stack, is Azure Data Factory, because that's the service that does ingestion very well. And please remember that apart from ingestion, it is also very good in orchestrating the whole process, in organizing it into logical steps. So this orchestration is also important, and it can be handled by Data Factory. If for some reason you don't want to use Data Factory, well, you could switch to Synapse, because Synapse, something like this. So let's say that this is a Synapse. Synapse is this unified tool that combines various capabilities under a single umbrella, under a single UI. And one of those capabilities are pipelines, which basically is the same as Data Factory. So if you don't want to use Data Factory, fine, use Synapse. Both would work just fine. But there are some cases when neither Data Factory nor Synapse pipelines would do the job. For example, the case of ingesting files from SharePoint Online. It can be done, but there are better solutions that can make it work. So in this case, you might want to switch to yet another service, namely Logic Apps. Logic Apps. That can be used just to fill those small gaps that are not nicely handled by Data Factory or Synapse, like various notifications, maybe refreshing your Power BI dataset, or ingesting a file. And the whole process is basically called ingest or extract. Various names can be found. But this is it. That's the goal. We want to grab data from the source and just dump it into our data lake. And from my experience, I would say that 90% of use cases can be covered by those three services. Of course, it doesn't mean that you have to use them. No, if you prefer to use something else and it works, fine, go with it. Maybe your company uses some framework or some external product like Fivetran that is able to connect to various data sources. Also, sometimes this data ingestion can be done better using a different tool. For example, I remember a case when we had to ingest data from Google Ads API, and we tried to do this by using Data Factory. It worked, but it was a very slow process. The performance was terrible, mainly because this API is quite complex, and the way it returns data is not that easy. So what we eventually did was to rewrite the ingest code into Python code, right? We switched from the Data Factory into Azure function that had some Python code written. And it was a game changer for us, because then the whole process ran much faster. It was easier to introduce changes. So please try to choose the best tool to do the job. You don't always have to try to do everything using Data Factory. Usually, it is a good choice, but there might be some cases where, well, it could be done better in a different way. Now, in case of Data Factory and Synapse, we know what has to be done in order to ingest the data that we have to create those things. Services, datasets, pipelines, and so on. And as a best practice, you should try to parameterize those objects, make them flexible, generic, but not too generic. Don't try to over parameterize because it might become too complex to maintain. So parameterize only if necessary. Then, because we are developing the solution in the cloud, and we should expect those temporary issues in connecting to various resources, it means that our processing should be able to detect errors and just retry the processing if that's possible. And Data Factory has this retry option capability available. But if it fails, then we should be notified about this. So it would be great if your solution just sent some type of notifications that, hey, something failed. And maybe you should take a look at the logs and see what changed. Then we spent quite a lot of time talking about security of our data lake, because, well, data lake, it is our central place in this architecture. It stores our precious data. So we have to make sure that access to it is restricted and controlled. And there are various ways we can do this. Some are better, some are worse. It's up to you to decide which one meets your requirements. And those various authentication and authorization methods, they are super important, not only for the data ingestion that we are doing so far, but also later when we start to consume this data and transform it. Because all of these processes or data consumers will have to somehow connect to our data in a secure way. So this knowledge will come in handy again. Then what we did was to talk quite a lot again about CI/CD for Data Factory. So basically how to make sure that we can quite easily deploy our changes to various environments in a repeatable way, automated way that reduces human mistakes. And basically, that's it. That's how our solution looks like. That's an ingestion phase in a nutshell. So let's move on to the challenge that should help you practice all of this stuff that I've been talking so far. All right, so the challenge. So let's pretend that we are working together. I'm the architect, you are a data engineer, and we have to develop a solution together. So let's start. All right, so dear data engineer, we just won this big contract and we have to start implementing this. And this solution that we have to create is about ingesting and processing data from replicable website that you should be familiar with. Right now, we'll start with the ingestion process. Later on, we'll move to other phases, but we have to start somewhere, and this start is the ingestion process. And I analyzed this solution. I prepared the initial architecture, and it will be your task to implement this. So let me describe what are the requirements, what we have to do. All right, so our data source is this replicable website. So let me write it down. Replicable. Our customer wants to have this data available. And actually, I checked this website and I found that it exposes two types of endpoints, two ways you can grab the data. So we have this download page that if you want just entire Lego catalog database, then use this download page. So let's go there and let's see how it looks like. And take a look. Here we've got links to various files that are zipped. So be aware that this data is zipped. And let's say that we would like to get all minifigs. So let me just click on this file. And we have this CSV file with data. So it is a CSV. That's fine. We can ingest data as CSV in the first phase. That is fine. So for sure, I would like those files to be ingested by you. What is also nice is that Rubricable gives us this diagram that shows relationships between various datasets. And that's super cool because it is often not the case. It is quite often you who have to figure out those dependencies between different objects. So please analyze this diagram. Try to understand the model of data that is exposed by Rubricable, because later on we will be querying this data, but that's in a later phase. So what I would like you to do is to prepare a solution that will allow us to ingest this type of data. And take a note that it looks that those files are uploaded or made available on a daily basis. It was done today at 8 AM, so an hour ago. So probably tomorrow at 8 AM, we'll have a fresh set of data available. So that's what we want to connect. So let's get back to drawings. All right, so we know that we've got those files. And be aware that they are zipped. So that's the first thing I would like you to ingest, those files. Secondly, what I also noticed, that not all data is made available through this download page, because here we only have this official Lego data. But what our customer wants to have is information about his Lego sets that he added to this Rubricable website. And I noticed, just by going through the API, that it exposes a REST API, actually two types of the API. So we've got this Lego source, which is basically the same stuff that is available through files. That's not what we want to ingest, so let me hide it. And apart from this, we've got this users source. And from here, I would like to ingest various types of data. So for example, I would like to get all of the minifigs that are in my sets that are registered on this Rubricable website. Or maybe I would like to get all parts that are in my parts list, that is again registered in this Rubricable website using given profile. So let's draw a second source. So we've got this REST API. So we've got two of them. Now, it will be your task to figure out how to authenticate to those sources, how to connect, how to get the data. And please take a look that in case of this users source, I can see, just looking at those endpoints, that we have to provide something called user token. At this moment, I'm not sure what this is, how to get it. So it will be your task to go through this documentation and understand what is required to make this connection work. All right, so these are our data sources. Now, I want this solution to be able to store data in a data lake. So as our target location will obviously have a data lake. That's what we are using in every project we do. So ADLS Gen 2. So this is it. And as a ingestion tool, so this is what we have to do. What you have to do, I would like you to use Data Factory, because I know that this is a tool that should be able to handle those two data sources. So Data Factory to be used. Now, I want to follow various best practices, so please make sure that our solution that you create in Data Factory is configurable. This is super important. And let me explain what I mean by this. So at this moment, I'm not sure yet which endpoints we'll have to query. I don't know. We'll get to it later. So prepare a solution in a way that it will be able to ingest any endpoint. And of those get endpoints, obviously. We don't have to care about those posts or delete ones. No, only get that we are interested in. But make sure that if one day we decide that, hey, we need to ingest yet another endpoint, all we will have to do is to add some entry to some configuration. And that's it. No additional coding in Data Factory should be necessary. So make sure that the solution you prepare is able to do this. The same with those downloads. At this moment, I'm not sure which files we're gonna need. But again, if one day we decide that we need one more file, I want it to be configurable. And basically, once we decided that yes, we need one more file, it should take you like 10 minutes to make it done. Because it should be configured somewhere, and Data Factory should just read this configuration and then extract and ingest the data that we need. You shouldn't have to code, implement any new stuff in Data Factory. So that's super important. It has to be flexible. Apart from that, please take a look that in case of those REST APIs, you might need to handle pagination. I am not sure how this REST API works, this users one, but usually those APIs are paginated, so they return data in pages. Probably we have something similar here, so make sure that it is handled. And you might fall into throttling issues. Throttling. So again, check how many requests you can make and then just adjust various settings to be able to process data without any issues. Alright, now on the data lake side, it will be your task to provision all those resources. Usually I would do this, but I'm super busy and it will have to be done by you. Sorry. So what I would like you to configure is, once you provision this data lake, make sure that it is configured in a proper way. So on dev environment, I would like you to use locally redundant storage, because it is the cheapest option and it is fine to use on dev. On our production environment, I would like you to set it to geo redundant storage. And yes, we will have two environments, dev and production. So we'll have to take care of both. Then I would like you to think about lifecycle management policy. Lifecycle management policy. Think about how it should look like and just configure it on our data lakes. Apart from this, think about access tiers. how it should be configured by default, which tier would work in our case, and just set it. And it is up to you to decide what option should be used. I give you here a freedom. I trust you. Alright. Then, about data lake. We want to make sure that the structure inside this data lake is correct, that we avoid this swamp when no one knows where our data is. So I would like you to follow this structure. So please create this row container that would be used to store our ingested data. Then under it, let's create this replicable directory to indicate our source. Then, because we'll be ingesting various data sources from replicable, we have this Lego dataset, which contains data about minifigs, sets that were produced by Lego, and that's the part that will be ingested from files. So I want to have it separated from the stuff ingested from API. That's why we have this Lego directory. Then inside it, please create directories for various datasets. So we would have data set 1, for example, for minifigs, or whatever dataset we decide to ingest. Then I want it to be partitioned by ingestion date in a way like this: year, then month and day. And finally, we would have files at the lowest level. And the same pattern should be repeated for every dataset we decide to ingest. So we would have dataset 2, that would have year, and so on, right? And now, because at this moment we don't know how many datasets we'll ingest, so this structure has to be created dynamically at runtime. The same with those ingest dates. We don't know when this process will run, so those directories have to be created dynamically. So this was about this Lego source from files, and apart from that, we've got this second source that was called users. And here I would like you to follow the same pattern. So we would have datasets, dataset 1 with some data, and so on. So you should see already how this data should be organized, right? And make sure that it is created in a proper way. Alright, so let's move on to data factory and some of the security stuff. So please figure it out how to make sure the data factory is able to connect to this replicable files and REST APIs. I don't know yet. It's up to you. Probably some kind of secrets will be necessary. So if it is the case, then make sure to create a key vault if it is required, and then store secrets inside it. Don't hard code it anywhere inside our solution. Then, whenever possible, please use managed identities of data factory to connect to various objects. If it is supported, it should be, but please double check this. And instead of granting access to some resource explicitly to this managed identity, please do it via intra groups. So create as many groups as you believe is necessary, add the managed identity to this group, and grant permissions to those groups. When it comes to accessing a data lake, I believe that airbag approach should be fine. We don't want to use any of those anonymous methods. ACLs are not necessary here, so airbag should work just fine. Just make sure to set and to use a proper role. Then our data factory, it should be run, our processing, it should be run according to some schedule. So let's say once a day. So make sure to create this object as well. And it should connect to those both endpoints, to those files and REST APIs, and just dump the data to a data lake. And it should be configurable, it should be flexible. So it should be quite easy to determine what files or which endpoints from the API we would like to query. Now, I know that from time to time this solution will fail, so please make sure to add some kind of an error handling. So whenever it fails, I would like to be notified by the solution. I want to receive an email that, hey, something failed. And finally, what I would like you to do is to make sure that your data factory code is stored in a code repository. So don't work in this live mode. No, make sure that it is integrated with code repository. Maybe Azure DevOps would be a good solution, and just follow best practices. And because we have those two environments, dev and production, we have to have a way to deploy our data factory code to dev and prod. So make sure to implement some CI/CD pipelines. And you can choose whether you want to go with ARM-based approach or selective deployments. Decision is yours. Just make sure that you wouldn't have to deploy it out manually. It should happen automatically. And finally, all of this stuff, all of those resources, I want to have them repeated because I want to have both dev environment and prod environment. And in our case, let's just create separate resource groups. So we would have a development resource group and production resource group that would simulate our prod environment. And that's it. That's the solution that you should be able to implement. I know there's quite a lot of things to be done, but I believe you should be able to do this without any issues. In cases where something is not clear or those requirements are not precise enough, it's up to you to decide how something should be done. I trust you. Just use your instinct and choose the best approach. Alright, so this is the challenge for you guys. I know quite a lot of stuff. It will take you some time to implement all of this. But I believe that it is worth doing, because if you do this exercise, then you should be fine about the ingestion process. It would mean that you understand this and you can do it without any issues. And now, I know that we didn't cover this files data source, we didn't cover this users API, but that's the reality of a data engineer. Quite often, you would have to work with data sources that you don't know. So it will be your task just to dig into documentation, play around with those data sources, and try to figure it out how it works. Go to Google, search on Stack Overflow, ask ChatGPT, whatever. You'll have to make it done. Alright, so that's the challenge. And now there is also a prize or reward for the person who completes this as the first person out there and somehow proves it to me that it has been done. Namely, I have a voucher for this SQLDay conference that is happening in May in Poland. That's the biggest conference about the data in Central and Eastern Europe. It's a great conference. And what I have is a voucher for online attendance to those 2 days, to Tuesday and Wednesday. The Monday is about on-site workshops, so that's not included, but those 2 days are included. And now this conference is super cool. There will be a lot of speakers that are top class ones. So take a look at the agenda. So for example, we've got James Serra, super knowledgeable guy. We've got Ola Hallengren for the first time on SQLDay. That's a must-have session for me. We've got Kevin Chant, that again talks a lot about Fabric recently. We've got a lot of speakers that are well known in data world. And please don't be confused by the name of the conference, SQLDay. No, it's not only about SQL. It used to be in the past about SQL Server, but right now it's all about data, including Azure, as you can see by those sessions. We have Paul Andrew in the agenda, right? That talks about end-to-end analytics. So I think you guess what thing he'll be talking about. We will have Kamil Nowinski, who will, guess what? He will talk about data factory and the challenges you would have with deployment of this stuff. So a lot of cool speakers. So I think that the price is quite nice. And this conference is held in Poland. So some of the sessions will be in Polish, but as you can see, many of them will be held in English. So even if you're a foreigner, if you don't speak Polish, you should be able to always find a conference that would be interesting and in English. So yes, so that's the prize. The first person who completes the challenge will get the prize. And I hope that there will be at least one person who does all of this stuff. And I would like to thank you, SQLDay board, for providing this online free voucher for me. All right. So that was it. So we finished the ingestion phase of our solution. It took us quite a lot of time, but I believe it was worth it. Now you should have this basic knowledge about the whole environment based on which we'll build later phases. And starting from the next episode, I will start talking about, alright, so we have the data in our raw layer, what next? How do we proceed from this point? But that's for the future. So that's it for today. Thanks for watching. Have fun with this challenge. And see you next time. Take care.